Good. So now we get to the other interesting part, having our special guest here. Let's go to the next slide, please. We have Calvin Leather. Calvin is with Embark. So Calvin, please unmute yourself, introduce yourself, and tell us, more about Embark and the research operational data flows. Stage is yours.
Great. Thanks, Martin. Hey, everyone. This is Calvin from Embark Vet. I'm an engineer and I wear a whole bunch of hats here. I do statistics, computer science work. I love dogs, I love statistics, and I love hiking with my dogs while thinking about statistics. So yeah, next slide. I have a bit more intro on Embark. So yeah, we're Embark Vet. We're just to start us off, I have a quick thank you to my colleagues who helped do a bunch of the work that I'm going to talk about in the slides. So all my collaborators on the infrastructure engineering team in that first group, and then all my collaborators on the discovery platform team, some of who are on this call. So yeah, next slide. So Embark Vet, briefly, we're a direct-to-consumer canine dog genetic testing company. So we're sort of similar in function to what 23andMe or Ancestry.com do, but we focus just on the veterinary market with dogs. And the company started, and its goal is to end preventable diseases in dogs by improving dog genetics and access to testing. Dogs are a really interesting species from a science perspective because they were bred over many years. There's lots of interesting genetic things going on. Next slide. So concretely, what this means day to day for us is we have lab data coming in, raw data coming into an S3 bucket, you can think of it, from a number of biological assays, things coming from fancy machines at a lab. We do that daily because people are constantly sending us their dogs' cheek swabs to get tested. We produce process data from that raw data, and that process data feeds into customer-facing products that say, hey, your dog's at risk for this disease, or hey, we suspect your dog's age that you didn't know is this. And then we also do a whole bunch of research to try to develop new products, new tests, new diseases we can test for. So I have some animations or next pieces to this slide if we move it along. So the customer-facing products are statistical or genetic-based data processing to identify or predict health condition risk. So we can distinguish healthy dogs from sick dogs based on their DNA with some simple and some more complex statistical methods. And then we do some other fun things like predicting the dog's age for dogs that were, say, adopted, or trying to figure out their breed composition. Is it a boxer or a Labrador? On the next slide, we also do a bunch of research work. And so that's doing a lot of statistical analysis with some pretty typical methods if you've done any sort of prediction modeling, some that are more genetics oriented. And a lot of that is you have a whole bunch of features for each dog, hundreds of thousands of them, because you have a lot of DNA. And we have a whole bunch of disease information, which we actually model with DBT. I didn't put that in the slides, but we actually probably should think about the DBT plugins. We have a whole bunch of also structured health data that we get. People report, they do surveys for us. We collaborate with academic collaborators, and we try to find associations, new products that we can offer, new diseases we can test for. So with this comes some interesting engineering challenges. We have a mixture of production data flows. We have customers constantly sending us cheek swabs from their dogs and other biosamples. And every day, more and more data is flowing through that needs to get analyzed and processed. But then we also have these research flows where we want to take that data and then use it to do discovery work to help improve, to understand new health outcomes for dogs. So there's cost impacts on the operational side. There's sensitivity to errors and bugs. This is not a research workflow where we can send in correct results and then fix it later. We have to have a lot of confidence in our processing. So that was one of our interesting challenges that originally set us down the path to landing with Flyte. But there's some other interesting ones too. Very wide data, very large, lots of binary data formats. It makes it very hard to go with something that's very structured for I don't know, event-driven data processing or some of these other architectures that are designed a lot around protobuf or JSON messages that don't have S3 backing. So And last, there's some interesting pieces around. We have a number of products and we have a number of teams, each of which might have different science backgrounds. And those all have to interact in complex ways that meet all of these previous requirements about safety and security and cost. So coming from that, that was sort of our quick idea of our requirements. We started exploring Flyte and other tooling a little over a year ago now. If we go to the next slide. Here's a quick image of once we shifted to Flyte, here is our DAG of one of our actual customer facing products, the final sort of workflow, just to give you some idea. And a number of those sub workflows, there's a lot of reference workflows there, are different teams. So there's a lot of complexity there about pieces of data being passed around. And so, yeah, if we go to the next slide, we started down this path of doing a trait analysis because we had some internal built tooling from Embark's early days. We're at about 6 years old now. And we were looking to try to lean on the open source community and use standard tooling for some of this more complex data processing. So we explored a bunch of things, some from sort of the scientific world like Nextflow or Cromwell or SnakeMake, and then some more typical ones if you've worked in data science, data engineering. And when we got through this big exploration, we ended up picking Flyte for a few reasons. The next slide has some quick ideas of them, but the biggest one was if you have a big, complex cross-team system and you want it to be very easily testable and very well understood what outputs of one thing are and how they feed into the next component or next task, the way that Flyte's type contracts that you can create sort of with the Flyte types was really powerful and was a lot better than a lot of our experiences working with some more scientific schedulers. But then there's also a whole bunch of other things around performance and support for Kubernetes and also being able to use batch if we want that we really liked. So we got out of that trait analysis and we picked Flyte. We did a whole bunch of exploration with different tools. And yeah, I think the last one is probably one of the more interesting ones that I've always been curious about coming from other schedulers is there's a lot of interesting support for large DAGs natively. One of the patterns that I've often seen is your scheduler doesn't get to understand the scale of the jobs. It sort of says, hey, I'm going to go ask Spark to run this huge job. And that's fine for certain things. Like there are certain things where you're doing a big aggregation job with Spark and the scheduler wouldn't really have much to do there. But when you have a lot of massively parallel jobs, bioinformatics has a lot of these where you're processing the same dog and doing different things on it serially. Letting the scheduler reach in and understand and have a large DAG can be really nice because it can start to do smart things about handling errors and passing data around better. So that was one of the sort of more unique things that it wasn't just Flyte did better, it kind of just did differently than a lot of the schedulers we were used to. So yeah, that was sort of our quick summary of our trait analysis. Let me know if anyone has questions. There's the next bit where we talk about some of the things we've been doing with Flyte that we really like.
Maybe just one question,
Sure.
Calvin, there on the trait analysis. I mean, for a team to really go through, who initiated this? I mean, not whose name, but what kind of role was it? You and your team? Was it more data science initiative, or from which department did it come actually initially? More infra?
Yeah, they came from the team used to be called the infrastructure engineering team. So it came more from sort of a mixture of SRE and more operational science folks. That was where it sort of started from, was we looked at the growth of our product and the number of products we're offering. And we realized we have to have one tool for workflows just for our operational tooling. We can't like do some things in a Lambda and some things in something else, and that's going to get unmaintainable. And then once we saw that need, we realized, oh, our science groups need all of this too, in our more operational science groups, because they also have big compute jobs that they need EC2 instances for, and we could give them a lot better of an experience.
Got it. So, I mean, the other point for the community is if somebody's watching this right now and thinking about how do I get started with Flyte, who do I involve on my side, in my team? What do you think is the right team? Do you think it's a cross-functional team to begin with, or should somebody just take the lead and try it?
Yeah, good question. I think I think it depends on who your teams are too, and the type of culture you have in your science groups, especially. Like there are some companies where the science groups are really want to get their engineering hats on. And there are other companies where it's like no, come to us once, like we don't want to have to deal with we don't want to deal with Kubernetes. We don't want to deal with like IP exhaustion.
Right.
So I think that would be what I would recommend is think about your company. Going to like an SRE style group would be great if you have more of like a company where science wants a more polished platform. If you're a smaller startup and you have more interaction, yeah, totally get that cross-functional team from day one, and you'll probably have better outcomes for like those really small teams.
Awesome, thank you. Yeah, I think it always takes like kind of like the data scientist who thinks more operationally and production wise, or the infra person who thinks more about how can I get my data scientists, my researchers. And once you have somebody who can actually wear two hats at the same time, you actually pave the way for a solution like Flyte.
Totally. Yeah,
Okay.
It's hard otherwise without that shared vision.
Yeah. Okay, fantastic. Thanks. Please carry on.
Yeah, so this is just gonna be a quick overview of some of the things that we've really liked that we've been able to do with Flyte lately. So one of them, a lot of our science work happens in notebooks for sort of the exploration piece. And there's often a stage where that exploration piece then needs to get really big with a lot of compute. And so I've seen a few scenarios. I think one scenario that I've worked in the past is like that is always handled because by having your notebooks hooked up to a Spark cluster or a DAS cluster or something. But one of the interesting things that we've been playing with is the notebook can sort of drive the Flyte cluster using FlyteKit remote. And so we've gotten this really cool setup now where a couple of our really common workflows that people can launch via the Flyte console, we have relatively good docs for how to call them from other places, including from Jupyter notebooks. And people have gotten used to this a little bit. So some of our core science tools that you use repeatedly, imputation is one of them for folks who do bioinformatics work. You can just sort of say like, hey, give me imputation, and it'll go launch 40 spot instances, which are cheaper than your on-demand instance that you're using for your notebook. And then it'll return the results back in memory, which is really neat, depending on what the results are. People don't even have to understand what was going on the Flyte cluster and how the data got back. They'll just get back the outputs object, and they can do outputs.get whatever. The next slide has an example of this. But yeah, like this is an example workflow. This isn't the imputation one. But this is loading a large file and pulling out a piece of data from it. And you don't have to pull the whole file to your machine because it's a big one. But you want to pull out some of one of these columns. And it's really nice because they can grab this code block that fetches the task and executes it, and then just grab the output. It comes back into memory. And I think there's a lot of low-hanging fruit there I've spoken about this a little bit with some other community members, like some Flyte types that are specific for certain problems, where they could, just like the structured data set, Pandas Parquet one, could do some of the work to get the data back into memory. And then you have a really easy way to get that sort of, yeah, I like that word, scalable exploration, like create a more closed loop process where there's a dance with the Flyte cluster. So yeah, that was one of our favorite features that we're trying to lean into a lot at the moment.
If I might just chime in here, I mean, I think that's a usage that actually is very interesting. Do your data scientists use this in the discovery process when they impute something and see what imputation works well, just need a big compute power, and then once they get this right, then they actually go into the workflows after that? Is that how it works?
Yeah, so we're actually just starting to talk about using this a lot more for hyperparameter optimization, which is where this is going to get even more like useful to launch at scale. But yeah, like there is a sort of like, yeah, the way that it works with imputation is imputation basically, it's like it is in any other data science realm where you're filling in missing data that we don't have. In our case, it's because we only collect from DNA about 250,000 features or 260. And in reality, the number of DNA locations that change in dogs is in the millions. So we can impute those locations and then run more analyses. And so, yeah, that's often the workflow is like, hey, you think there's something there. You want to get more of that imputed data, which can rely on some unlabeled data to do that imputation, and then pull that back in and do another model fit, another round of exploration. So that's the really common one right now. But yeah, hyperparameter optimization is going to be a great thing for that, where you have a start to a model and you want to queue up a whole bunch of work.
Yeah, I think what you just described is actually is something very interesting, because what you do is like you make this more of a circular motion versus a linear motion, right? The linear motion is let's research, let's build a model, let's deploy it. Where you as right now say, well, I have a platform and I can actually, pick things in areas of interest. After I have my model already done, and if I want to impute differently by averages or whatever else I want to impute by, then I can do this here and actually keep going and making my models of whatever I have my workflows better. So I think that's a very important point that you're making here right now.
Yeah, go ahead.
Go ahead.
Oh, I was gonna say that closed loop, that iteration time is totally what we're trying to get at here, and trying to bring that down for many things, that some of which are data science, some of which are even more biology oriented.
Great, fantastic, I love it.
Yeah, Calvin, just real quick, this is really cool. Just seeing this slide, because just the what I said in the chat, just like scalable exploration has always been a pain point. And you typically you typically would have to buy into a vendor to say like SageMaker notebooks or whatever. But yeah, I didn't even really anticipate that you could use Flyte in this way. I mean, obviously it's supported, like you guys are using it that way, but yeah, I would love to like somehow encode this into some kind of best practice, because this is the first time I'm seeing it used in this fashion.
Yeah, I know, and I know I've been on a ticket. There's a ticket somewhere in the Flyte project to talk about like getting data out from executions in notebooks, and I hadn't really put 2 and 2 together until about a week ago. But one of the things you could really probably support without too much work, right, is if you could code gen these blocks out of the console, right? You can go to anything in the console that's already executed and grab the thing to get to fetch the execution, and grab the outputs. And that takes care of all the transformations using the existing transformers for the Flyte types, which is really neat. There's no new code that you have to write to support that. So yeah, I'd love to keep talking on that front.
That's awesome. I mean, and I'm totally with you, Niels. I think that's when I saw this right now, I felt like this is actually a very interesting way of using the platform and the compute that you have on the back end, and giving researchers like kind of like at the moment what they need, and actually overall have this circular motion of making things continuously better. It's fantastic. I love it. Okay, please carry on.
Cool. Yeah, we can go on to the next one. I have another one of my favorite things. So this is another one that we've been doing a lot of thinking about, and I think this is one of the areas of Flyte I'd love to see more, like as a community, us defining or describing how different companies have done this. So as I alluded to before, especially for operational data flows where you need stronger guarantees and you want to write better tests, having sort of static testing or pacts between teams that are based on those Flyte types is really nice. So what I mean by that, we have a team that does a lot of our QC analyses on data that comes in. They have a lot of like biochemistry folks that understand what goes on in the wet lab really well. And then we have another team that's really thinking about predicting the health conditions of dogs. And that QC team needs to pass out like the QC'd cleaned up data to that downstream team. And there's a handoff there that in my experience is always a really great place for bugs to creep in when you have those sorts of like differing expertise of the teams, like data engineering and data science teams. If you have those structured that way, can also have the same thing where like there's a miscommunication in what was produced by one group and what went into another. And in the web world, there's a lot of discussion of using pacts and cross-team testing and strongly typed contracts. And that's something that I feel like is still building up in if you're doing work that has much bigger data sets and can't just be events that get passed around. Like we briefly explored using completely event-driven systems for this, and it was really challenging to figure out how to do that well with, like, we have some data sets where it's a gigabyte per sample, and like, are we going to pass around the S3 path to that? It's going to get messy. So one of the things that we're really getting into that we really like is you can use custom data classes and things to define that contract between the teams. So each team imports this library that has that common definition of here's the data class. As a bonus, you can even use Pandera and get even more detailed on describing data frames and things. And then Flyte takes care of a lot of the sort of like backend details to get that into protobuf and get it so that 2 different containers running on the K8s cluster can get the data between them. But when you go and you register, you get a nice static check right then and there that, for example, like the upstream team didn't change their type definition. When the downstream team goes to register, and there's this example here, when you import that reference workflow, you'll get an error if you miss something that they changed. So there's some things like that we're really trying to lead into to try to create this, like bring over this concept of packs and cross-team testing, and use some of these Flyte features to achieve it. And there's a even stronger example on the next slide that we're using for some of our production products. And this is one of the interesting patterns that we're still not quite sure we like how we did it. If you have a whole bunch of teams that need to come together into a final bigger workflow, one of the patterns that we're using for this is we have sort of a lock file that's in one location, in one repo that deploys, and all it has basically is reference workflows that reach out to the other team's workflows and say, I pin this version. And it creates a really nice setup where each team can independently bump and re-register their versions of things and test them out and backfill old data, et cetera, in their dev set environment, and then bring that up to their prod environment. And it's only once they update that lock file with all those reference workflows that it actually goes live in production. But they can have it on the production cluster ahead of time and test it on test case data, et cetera. So there's some rough edges there, especially around the CI/CD, and I'll get into that when you have these like more complex reference workflow setups. But we have really liked getting at sort of the things that we're used to from the web development world for smaller, less data heavy flows of messages between services, for example. Yeah, so any questions there? Those are my two favorite things.
I can easily understand that those are your two favorite things. That's fantastic to see that. And also great to see Pandera being used there in order to really make sure that the packs between the teams are actually also validated via software. It's fantastic.
Cool. So we can go on. I have a couple points of things that we want to keep working on. And the first one is just around scaling EKS. It actually has nothing to do with Flyte, I think. There were some parts with Flyte. Thank you so much, folks on the Flyte side, like Dan, who helped us work through some of these as we were scaling. But I mentioned before, we love that Flyte can support really big DAGs. That also means that we have to support scaling up our K8s cluster pretty big. And we're running an EKS. So for anyone else who is thinking about going for a bigger production product with larger data flows, one of the biggest things that was useful for us was to really get our heads around the EKS CNI. That was one of them. That's details of how EKS does IP allocation, for example, are a little bit tricky for things that aren't websites with 1 to 100 instances. Like if you're going to scale up to 1,000 pods, it can get a little bit tricky. Actually didn't put this in there, but the other one to think about on that front that's EKS specific is the AZ rebalancing. That one caught us for a loop. AWS would take down our pods because it was putting too many in one AZ, and those pods were not hosting a website. So it's fine if there's an instability in an AZ that takes down 2/3 of our pods. It's not a big deal. So that was actually our biggest, like the thing that took us the longest to work through. And we're still scaling up our production workflows in Flyte to thousands of machines. We're still catching little edge cases and things that we're working through. Yeah, so the next one is this is the one I think is more interesting and more Flyte specific. So we have a lot of multi-container workflows, especially on the science side, where in bioinformatics, a lot of it is not import whatever, like whether you're working in Python or R or Julia. A lot of times there'll be steps where you need to reach out to a C binary. And like, there's a really common, you'll see lots of these workflows where it's either like Java, there's a few Java-based tools that have been put out by like Harvard or the Broad Institute at Harvard. And you need to keep calling them from your Python code to do some processing that someone has built really optimized Java or C code for. And that community hasn't, for example, picked up Python or something yet to build good interfaces to Python. And so you often have different containers because each of these binaries might be 500 megabytes a gig. So you don't want to have the Uber container with all of them. The registration gets a little bit interesting where let's say you have some data classes, for example, that define the inputs and output types of some Python tasks. And then you also have some bash script tasks that use those executables. When you go to register, the imports, wherever you're registering, all need to resolve. Unless you hide them in your tasks, which is an interesting pattern that I'm not sure I like. But I know there's a community ticket about this one. We dug it up a while back, but that's definitely one of the things we're trying to figure out the right long-term pattern for is when you have multi-container workflows, especially if they spread across repos because they're across teams, how do you think about the CI/CD and setting everything up right so that the imports will always work nicely and you don't need an Uber container to register from that sort of has all of the dependencies from all of the component workflows. And I think reference workflows can help with this, set it using them right, because then you can register all the things that have certain sets of dependencies. But it also can get tricky when you have like within the same workflow, you have 4 tasks, each of which has a different container and maybe a couple Python tasks in between them. So yeah, I think that's one of our biggest long-term points that we're pondering on and would love to talk with others about what they ended up doing.
Yeah, that's fantastic. I think that's a great topic. And I think we can actually also make sure we continue offline with that topic and then actually go to Slack and take this forward. It would be interesting to see what others have done.
Definitely, I'd appreciate that. Okay, and lastly, we have the things that we're working on. These are things that we want to keep playing with in Flyte and keep improving. Definitely the name of the game right now for us is training, really, I think, at least internally to Embark. There's a lot of good tutorials on the Flyte side, but they also they're written for people who are, for example, like a data scientist or maybe more of someone who has more of an engineering background. So one of the things we're working on is how to improve the understanding for folks that are coming from a high performance computing, a clustered computing environment, like a lot of our biology oriented scientists come from. There, it's often a little different. You have a job queue. You often submit bash scripts to get run on a remote cluster. There's a lot of similarities, but there's a lot of places where we have to get people around this operating concept, get their heads around it. Bash and Jupyter task supports we're continuing to work on. The bash task, I think, is the one with the most opportunities for improving how data gets passed in and out in particular. Like there are inputs. There's probably more that we could support to make it easier. For example, like having better environment variable inputs. We've done some exploration around that, and there's a helper task that my colleague Mike Zong wrote, but I think there's still more to do there that we can improve. And then the maybes that we're thinking about that are a little bit further is, I mentioned this before, like nicer Flyte types for some of the bioinformatics workflows that help take care of some of the work for you of manipulating disks, files on disk. We can use Flyte files for everything today, and they're good enough. But I think the low-hanging fruit there is things like there's a library called HTSlib. It's a C library for manipulating some of these bioinformatics files, and it has Python bindings. So we could make a Flyte type for that, so that when it comes back to the next downstream task, you already have the file has been downloaded like a Flyte file, but you already get that handle back that you can use in Python to manipulate it and do things. And then there's some interesting stuff around using F1 instances, I think, for certain things. I don't think we've seen anyone do that yet, but there's some interesting FPGA accelerated workflows for bioinformatics that a company called Illumina has put out. And we want to experiment with that at some point. I don't know if those are even supported in EKS. So that'll be an interesting one to explore. Yeah, and those are our main things that we're excited to think about in the coming months that really touch on Flyte and Flyte development.
Fantastic. So first of all, I just want to say thanks. I mean, this is a tremendous overview here, and I want to ask here the audience that we have and potentially some of the Flyte engineers and developers here if they have any questions and feedback for you, Niels, and maybe Dan, just reaching out. Any comments, questions?
Yeah, I have a quick one around the multi-container stuff. I guess I didn't quite understand the issue that you articulated there. Because I know there's the multi-container like guides, right? How do those, like, what's the gap there between what you want and what is currently supported?
Yeah, let me pull this up just to remind myself that I'm not misspeaking about that guide, because we definitely looked at this one. So let me give a much more concrete example. Let's say you have a Python task that needs scikit-learn and another Python task that needs PyMC3. And you want to have different containers for those for whatever reason, because they're big. If you put those in the same workflow together without using a reference workflow, right? The imports, the import scikit-learn and PyMC3, those will get called during registration unless they're put in the function definition, right? So
Gotcha.
yeah,
Yep.
so you need the registration container needs to have the superset of the dependencies. That doesn't happen for bash tasks. Like for bash tasks, this is fine, right? Because during all you need to have is the path to the bash script. But we have a lot of tasks where it's like a dance between, we do as little as we can in the bash script. And we try to do most of our data processing in Python or something where we can have static type checking and unit tests, et cetera. So that's where this comes up, is that interplay between, we'll have smaller containers so that we can have pieces of processing structure. But if multiple of those are owned by the same team in the same repo, people often don't want to use reference workflows among their own, like the tasks that they own and compose into a workflow just in that sort of the private tasks, right? Like private methods.
Yeah, that makes sense. Yeah, I mean, I have seen other frameworks, like orchestration frameworks, that solve this with the imports inside the function. So, I think I agree with you that it's doesn't feel supernatural, but other people have done it that way. So it seems like you either do some kind of lazy import thing at the top that's like a special import function, or yeah, you import it directly or like inside the function body of the task. Yeah, that is an interesting problem. Thanks for clarifying.
All right. Any other questions for Calvin or comments? All right. So I have one last question for you, Calvin. How many dogs do you have, and what are your dogs' names?
I have one. I'm looking to see if she's in her bed. She's not. She's out in the living room. I have a Wheaton Terrier named Trixie. She's 2 years old right now. That's my one and only.
Okay, awesome. Okay, good. Trixie's a good girl. That's awesome. All right. Hey, Calvin, that was fantastic. Love it. I think this is a lot of good inspiration, a lot of inspirations here as well. So let's make sure we can carry on the conversations on Slack.